What's up, guys? Mr. Moore here. Let's try and answer the last couple questions on the test, and then I'll do the part 2 questions in a different video. So, number 16, a cart travels with a constant non-zero acceleration along a straight line. Which graph best represents the relationship between the distance the cart travels and the time of travel? So they're telling us that a cart travels with a constant non-zero acceleration. So pretty much this is just a constant acceleration. So if we were looking at an acceleration versus time graph, it should look something like this. That's the constant acceleration. That's what constant acceleration would look like. But they've given us only distance versus time graphs. So which distance versus time graph goes with constant acceleration of this? And that's going to be like something sprinting, like a person sprinting, or free fall when you drop something. All right, the distance is going to increase continually in a concave up fashion. Let me extend my graph a little bit. So your distance versus time graph should look something like that. This is for constant acceleration. Number 17. So base your answer to the following question on the graph below. During a 6-second time interval, what's the total distance traveled by the car? They've given us a velocity versus time graph. Alright, it looks something like this, and then it peaks out here. This number right here is about 10. Alright, and then we have 6 seconds right here. 6 seconds. So if we want to find distance from a velocity graph, we have to find the area underneath it. So in order to do that, we can break this up into 2 shapes. We can find the area of this shape here, find the area of this shape here, add the 2 together, and that'll be our total. So the area of the triangle goes from 0 to 4. So area of the triangle is 1/2 base times height. Right, the base is 0 to 4, so the base is 4. The height is 0 to 10, so the height is 10. And then 1/2 of that. So the area of the triangle piece is going to be 40 times 1/2, which is 20. And now we have to find the area of this rectangle shape over here, which is just base times height. The base is 2, the height is 10, and then we get 20 as well. So all in all, we should get an answer of 40. So let's look at number 18. So the graph below represents the motion of a body moving along a straight line. According to the graph, which quantity related to the motion of the body is constant? So if we have a velocity versus time graph, and it looks like this, which one of those following quantities is constant? So this velocity versus time graph goes with 2 other graphs. It goes with a distance versus time graph, and it can go with an acceleration versus time graph. If the velocity is increasing, the distance is going to increase in a concave up shape, kind of like this one here in 16. And in this case, the acceleration is also going to be constant. So these 3 graphs all go together. So in this case, what is constant? It's the acceleration. Alright, so number 19, 20, 21. So we have a graph. We have 2 cars, A and B. Question 19, what is the acceleration? So question 19. What is the acceleration of car A during the interval between t0 and t60? So what is the acceleration of the car from 0 seconds to 60 seconds? So we know that acceleration is equal to delta v over t. So we need to find delta v. So that's the final minus the initial over time. In this case, the final speed, so at 60 seconds, its final speed, it's at 60 meters per second. And its initial speed, so at time 0, is 0 meters per second. The overall time, so from start to finish, was 60 seconds. So in the end, we're going to get 60 minus 0, which is 60 over 60. We're going to get 1 meter per second squared. Number 20. How far did car A travel in the interval between T0 and T60? So in this case, they're looking for the total distance traveled. If we want distance from a velocity versus time graph, or speed versus time graph, we need to find the area underneath. So in this case, we have car A, it's making a triangle shape from 0 to 60 seconds. At 0 seconds, its speed was 0, and at 60 seconds, its speed was 60 meters per second. So we just have to find the area of this shape. So that's 1/2 base times height. Our base is 60. Our height is 60. And multiply it by 1/2. So in the end, we're going to get 3,600 divided by 2, 1,800. And that'll be meters. So, how about 21? During the time interval given below, which car traveled the greatest distance? So car A from 0 to 30 seconds. So from 0 to 30 seconds, car A went from 0 meters per second to 30 meters per second. So it's pretty quick. Car A from 30 to 60. So from 30 to 60, you got to remember now the car's starting at 30 meters per second and it's accelerating to 60 meters per second. So it's clearly going much faster from 30 to 60 seconds than it was from 0 to 30 seconds. And then car B has a constant speed the entire time, but we can see that it's got to be car A from 30 to 60 seconds. Alright, car A at 30 seconds, it starts at the same speed car B is going at 30 seconds. But then car A gets faster and faster and faster, so its distance is increasing, right? It's covering much more distance in the same amount of time as car B. Alright, also for question 21, you could have found the distance for each of those intervals by doing the area underneath the graph. Alright, so if you took your graph and we had car B, I'll do that in red, that's white. Let's grab some red. So if we had car B and car A, you could have found the area underneath the graph for each interval that they were talking about. So for car B, you could have found the 0 to 30 seconds, you could have found the 30 to 60 seconds. For car A, you could have found the 0 to 30 seconds, or the 30 to 60 seconds would be this entire area, which is why its distance is greater. Alright, so 22. Using the information, construct a graph. Alright, this is simple plotting. Most of you guys got this. Alright, it looked like you plotted your points something like this, and you had a best fit line like that. So that would be 22 and 23. Pretty sure most of you guys got that right. And 24. Using the graph, determine the acceleration of the car. Acceleration is delta V over T. So delta V, it's the final minus the initial. It's not always the biggest minus the smallest. It's the final minus the initial. So in this case, the final speed was 4 meters per second. And the initial speed was 24 meters per second. And the total time elapsed was 4 seconds. 4 minus 24 is going to be negative 20 meters per second over 4 seconds. Got my S's. This is going to be equal to negative 5 meters per second. And that should have been your final answer. Alright guys, so check out part 2. It's going to be all of the part 2 questions.